In our next video, when it comes to the Enterprise Layer 2 section, what we're going to be focusing on is trunks. We need to understand why we need a trunk and how a trunk is going to aid us doing our job. Now, there's a lot of different options that we have available to us in terms of setting up trunks, whether we want to do it statically or dynamically and things like that. But the main thing that we need to understand is the purpose of the trunk, right? The purpose of the trunk is to allow multiple VLANs to traverse a physical link between two switches. That's its ultimate goal. I mean, that's all it lives for, and that's all it lives to do. Now, in terms of how we're going to be configuring this stuff, not much goes into it. I mean, it's kind of a no-brainer config. Set the encapsulation type, and then set the mode. Once you've done that, you're squared away. There's really not much more to it than that. So in the previous video in VLANs, what we took a look at is going through and allowing switch 29 to create a VLAN of 11 to allow R25 and R26 to communicate with each other. Then we flipped the script, and then we created VLAN 12 on switch 30 and switch 31. And then we placed R28 and R27 that both attached to gig 1/1 on each of their switches respectively into VLAN 12, but the ping did not work. So the way to fix that problem is to take the connection between switch 30 and 31, which in this particular case is going to be gig 0/0 on both sides. We need to configure gig 0/0 on both sides of switch 30 and 31 in order to propagate that VLAN information, or to assign a tag. And that's really what the trunking is designed to do. You take, anytime you send traffic from 31 to 30, or 30 to 31, whichever direction you're going in, as traffic flows from R28 into switch 30 over gig 0/0, as the traffic goes out towards switch 31, switch 30 is going to apply a 4-byte 802.1q header just ahead of the layer 3 header, meaning before it. So after the layer 2 header, right before the layer 3 header, you're going to place a 4-byte field. Inside that 4-byte field, you're going to have a 12-bit section that's going to be dedicated to the VLAN ID. So what's going to happen is switch 30 is going to set a 802.1q header that says, okay, you know what? This is VLAN 12 traffic. So it's going to set the traffic with a tag of 12 and send that traffic down to switch 31. When it does that, switch 31 will receive that and decapsulate it, meaning pull the 802.1q header off, and then place that traffic inside of VLAN 12 where it belongs. So one thing we're going to do is I'm actually going to pull up Wireshark on gig 0/0. So go ahead and set that up real quick. I'm going to launch Wireshark while I'm working on that. And we're going to see a fair amount of data coming across and stuff like that. But for right now, I'm going to bring this up here, and I'm going to isolate this to ICMP. And right now, we don't have a whole lot going on. So I'm going to go ahead and I'm going to pull Secure CRT back up. And let me go ahead and scoot this over just so you guys can see how this all comes together. And what we're going to go do is, let me go ahead and pull this down just a touch so it's easier to see. So on switch 30, what I'm going to go do is I'm going to type in interface gig 0/0. Go ahead and jump out of the way real quick. I'm going to type in switch port trunk encapsulation.1q. By typing this command in here, I'm setting the encapsulation type, which is going to be the very first thing that we need to do. I type that in, and I type in switch port mode is going to be trunk. Okay? Now I've done that on switch 30 side. So if I look at switch 31, and I do a show, let me go ahead and host name is going to be switch 31. If I jump out of here and do a show interface trunk, you're going to see that on gig 0/0, that the encapsulation type here has been set to negotiate. Now let me go back to 30, and let me come in here and type in OR DTP. And what I'm going to see here is you're going to see right here. The dynamic trunking protocol kicked in and said, you know what? You're going to become a negotiated 802.1q negotiated trunk. So that happened. So we have that. So what I'm going to go ahead and do now is on 31, we're squared away there. We can see that VLAN 12 is allowed on gig 0/0 and everything is squared away. If we do a show VLAN brief, we can see that gig 1/1 is on R27 that's connected. So if I go back to R27 and I do a ping to 10.1.2.28, the ping goes through. Now you'll notice that all of a sudden now, let me go ahead and pull this one out. Let's just do ICMP. If we look here, let me scoot this up just a touch. You'll see that I have a ping coming from 10.1.2.27 and inside of the 802.1q header. So remember, it's right ahead of the Ethernet frame. So this right here that I'm highlighting, this is the layer 2 header, this is the VLAN header, and then we have the layer 3 header. So inside of here, we're saying this is VLAN ID 12. And then we have the ether type value, IPv4. Come down here, it's an IPv4 packet going from 10.1.2.27 to 10.1.2.28, and it's an ICMP, or an Internet Control Message Protocol, and it is a type code 8 and a type of 8 and a code of 0. So a ping request, we come back up here, we have a type 0 code 0, an ICMP reply. But we look a little further up, we can see it's a VLAN ID 12. So that's it. That's all we have to really know about how this process comes into play, is that we know it's VLAN ID 12. Traffic comes in on that port and everything is good to go. So that's basically how that would come in and operate. Now the next step that we need to understand is going to be, what if we don't want to negotiate? What if we need to go look at this from another perspective? Let's say we don't want to negotiate. Let's look at switch 31, and if we look up here, we can see we're negotiated. So if I go to global config, and I type in interface gig 0/0, and I type in switch port trunk encap.1q, switch port mode is trunk, and I type in do show interface trunk again, now that port has been set to the mode of on, and 802.1q is the encapsulation type. So now we have traffic going back and forth, and everybody is happy. Everybody's on the same sheet of music in terms of operations. Now let me go ahead and finish the configuration. We're going to go on 31, we're going to type in, fortunately for me, all of the trunking is the same range, so we'll type in interface range gig 0/0 through 3, type in switch port trunk and cap.1q, switch port mode is trunk. So we'll go ahead and do show history, and I'm going to take these few lines of config and I'm going to jump onto switch 30, and on switch 29 we'll get all of them configured, so they're all on the same sheet of page, or same sheet of music. So now that I've done that, and I come out of here and do a show interfaces trunk, we're going to see that VLAN 1 and 11. Now, we currently don't have VLAN 12 configured on switch 29. And that's okay though, we don't need to have it there. And the benefit to not having it there is, one, when we have traffic from 28 talking to 27 or vice versa, what's going to end up happening is MAC addresses from here won't get pushed down to switch 29 because there is no VLAN there for the MAC addresses to get placed inside of, no spanning tree or MAC address table. Because remember, when you create a VLAN, you're creating a spanning tree instance and a MAC address table up to a certain point, right? Because if let's say that the switch only supports 100 VLANs and you create 200 VLANs, then there's only going to be 100 spanning tree instances and 100 MAC address tables. So then you're just going to have MAC addresses propagating everywhere, and it gets messy. So we come in here, we look at we have VLAN 11 is the only one that's allowed to come across, and that's okay. We're completely fine with that. So the next step we would have is to, and actually there is no other next step. This is it. So we are at the point where if we wanted it to go any further, we would need to go and start moving stuff around. So what I'm going to go ahead and do is I'm going to end this video, because that's pretty much what you need to know in order for trunking to work. We're going to take a look at, in the next video, the VLAN trunking protocol, where we talk about how we create a VLAN dynamically, we push it to the rest of the network, and what I'm going to do is I'm going to create VLAN 12 here dynamically, and we're going to place gig 1/1 into VLAN 12, and then we're going to allow 26, 27, and 28 to be able to talk to each other. That's my goal. With that being said, ladies and gentlemen, thanks so much for stopping by and hanging out with me in this video, and until next time, take it easy.